Here it is, quarter to 10 in the morning. I've been sitting here since about 9 o'clock working on some DiffyQ. Fun. I'll check in a little while. Today's all about giving you a peek inside the life of an engineering student. So, we're having fun with Laplace transforms this morning. What I'm doing is simply taking problems out of the book and working them out on paper. Practice. So what we're looking at here is an inverse Laplace transform. What I need to do is try and take this function and transform it into looking like something like this. So I look at this and I notice the first thing I could do is pull out a 1/4. So this is going to turn into 1/4 times the Laplace inverse transform of 1 over s squared plus 1/4. And I think I'm going to try and make it look like this guy right here. So I'm going to need this squared. So we're going to need the square root of that. Okay. We're almost there. This is going to turn into a 1/2 squared. We need to get a 1/2 up here. So do that. We're going to go 1/4 times 1 over 1/2. I'm doing that because if I have a 1/2 down here and a 1/2 up here, it's still the same as 1. All this times the Laplace inverse transform of 1/2 over s squared plus 1/2 squared. Now if we come over to our table, we have it in a form that looks just like this. So our inverse is that. So this all turns into 1/4 times 1/2, so it's going to be 4 over 2, which is just 2. So it's 1/2 times, so it's going to be 1/2 times the sine of 1/2 t, or as my teachers prefer to see something like this, t over 2. So now I come over here, go to Chegg. Chegg is a lifesaver. Look at the solution, number 14. We have it. Alright, well, for some more fun, I'll check in a little while. So, here it is, 10:30. I rolled out of bed and I've been sitting here for an hour and a half. As you can see, these things get nastier and nastier. It's the last problem I just worked on. I'm ready for a break, so I'm going to go exercise a little bit, and then I'll be back at it. When we return, it will be fun with physics. Splashed a little water on myself. Now I'm having a nice little cocktail of some vitamins, nutrients, and a ton of caffeine, getting ready to go do a little exercising, and my mind is on my boy Newton. So I'm going to turn to my favorite guy on the net in situations like this at tutorguy.com and watch a few videos on vectors as I drink my little drink.
Well, I've got this out.
So it's 1 o'clock. Just got home from exercising and eating a little bit of lunch. Now it's time to switch gears from DiffyQ to physics. Let's see what we got to do here. Yeah, got a little bit of a bit to accomplish tomorrow before 10 a.m. as well as get all lot more DiffyQ studying and attend a chemistry lecture. Check in with you in a minute and show you what kind of fun I'm having. So it's 2:15, still plugging away at some physics, working on number 31. Position of a particle is given by the function x equals 2t cubed minus 9t plus 12 meters, where t is in seconds. They want to know at what time is the velocity 0 meters per second, and what are the particles' position and acceleration at this time. So first, we know that acceleration of x equals 2t cubed minus 9t squared plus 12 meters. So velocity of x is simply going to be derivative of that. So we've got 6t squared minus 18t plus 12 meters. Meters per second. Our acceleration of x is going to equal 12t minus 18 meters per second squared. Now they want to know when does the velocity equal 0, right? Oh, and this is not here. That was a mistake. That's just going to be 6t squared minus 18. So when velocity equals 0, so we're going to take v of x, and v of x equals 0. So that's saying when 6t squared minus 18t equals 0, that looks like, to complete a square there, I feel lazy. I'm just going to punch into my calculator real quick. Alright, so t is going to equal 0 or 3. Now, at 0 seconds, acceleration equals, what position first? Position equals, and acceleration equals, and then they want to know 3 seconds. So in at 3 seconds, position equals, acceleration equals. So at 0 seconds, our position is going to be 2 times 0 cubed, which is 0, minus 0, because 9 times 0 squared is 0, plus 12. So we're going to be at 12 meters, and our acceleration is going to be 12 times 0 minus 18, so that's going to be negative 18 meters per second squared. At 3, our position is going to be, let's see here, 2 times 27 minus, let me take the calculator. Alright, so we get, right here we're going to be, our position is going to be negative 15 meters. Acceleration is 12 times 3, 36, minus 18 is 18 meters per second squared. Let's go to our wonderful friend Chegg. See if we are right. Think. Let's see. Yep, we got our 0 position at 3 seconds. Yep. 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 And correct. So it's 2:30. Got about halfway through my physics homework. Still got a bunch of workbook stuff to do, but it is time for me to get cleaned up and head to campus for the evening. Check in with you when I get there. It's 3:07. Just got to campus. I'm about to go into the tutor center and work on some physics for a while until one of my classmates from DiffQ may or may not get here. And then I have a lecture for chemistry at 5:30. I normally spend this time working on chemistry, but I got a really big DiffQ test coming up Thursday. It requires a lot of my attention. So that's the plan. It's 5 o'clock in the tutor center. Done with my physics and time for chemistry.
Kind of oriented nicely, because like water kind of looks like this, right? And you've got hydrogen bonding in water, so you got 2 pairs of electrons. So then you can have another water molecule over here because.
So it's 7:30 in the evening. I just got out of chemistry class and I'm about to head over to a buddy's house to study some DiffQ.
0 when t is less than 2, but it's going to be.
Right, it's 10:15.
when
I'm
t
leaving
is
these guys
greater
to
than
it.
or equal
I'm
to
going
2.
home. So it's almost 8 o'clock and I'm here with my buddy Bobby, or Joseph, waiting on our buddy Bobby. And we're gonna dive into some more DiffQ. So it's 5 to 11 p.m. I just got home. I'm fixing to lay my stuff out for the morning, go to bed, and start all over again tomorrow. This was my day.